Hello again. Welcome back to week 1 of the ECE9013 course titled Programming for Engineers. In this video, we are going to discuss some of the general aspects of languages and how they apply to programming languages. We will also discuss the basic types of errors observed in Python language and some of the primitive data types used in the Python language. So, all languages have what we call primitive constructs. So, for the English language, the primitive constructs are the words. In the programming language, these primitives can be numbers, strings, and simple operators. For example, we can see there is a string primitive, an integer primitive, a float primitive, a Boolean primitive, the addition and subtraction, all of these are primitives. Accordingly, we can have different types of errors. One of them can be in terms of the syntax. So, in the case of the English language, you cannot write the sentence live Canada I in, because this is not syntactically valid. Or I live in Xanada. This is also not syntactically valid because there's a primitive that is incorrect. The syntactically valid sentence is I live in Canada. The same applies to a programming language. For example, you cannot add a number to a string because this is not syntactically valid. However, you can multiply a float by an integer because they are both numbers. The second aspect or the second potential source of error is in the semantics. So semantics refer to the meaning. So although you might have a syntactically valid expression, it might be erroneous in terms of semantics. So for example, the sentence I eat beef is syntactically valid and semantically valid because it has a meaning. On the other hand, I eat car, although it is syntactically valid, semantically this is an error because you cannot eat a car. The same thing happens in a programming language. Syntactically speaking, 3.2 times 5 is valid, and it's semantically also valid because you can multiply a number by a number. In terms of the semantic way, what does it mean to add a number to a string? So, although this might be syntactically valid, semantically this is an error. So, as I mentioned, semantics is the meaning associated with a syntactically correct string of symbols with no static semantic errors. So, for example, in the English language, this means that the sentence or phrase used has an actual meaning, like, I bought an apple. For a programming language, you have only one meaning, but it may not be what the programmer intended. That's why it's crucial to make sure that the code developed is both syntactically valid and semantically valid. That's why we can divide the types of errors in a programming language into 3 different types. The first, which is the most easily caught, is the syntactic errors, which is an error in the syntax itself. The second is static semantic errors. So these may cause unpredictable behavior because syntactically speaking, you are using the correct syntax, but the operation that you're performing does not make sense. So this is what we call static semantic errors. Then there are the more dynamic semantic errors in which they would have a different meaning than what the programmer intended. As an example, infinite loops or logical errors, which lead to also unpredictable behavior. So a group of synthetically and semantically valid commands is what we call a Python program, or a program in general. So a program is a sequence of definitions and commands. Definitions are evaluated and commands are executed by the Python interpreter. So the commands instruct the interpreter to do something. So these commands can be typed directly in a shell or stored in a file that is read into the shell and evaluated. So a program basically manipulates data objects. These objects have a type that defines how the program manipulated them. So depending on the type, you can have a particular set of actions or commands that you can apply on. So these objects can be scalar and hence cannot be subdivided, or non-scalar, which means that they have an internal structure that can be accessed. Scalar objects include integers, floats, Boolean, and the non-type, which is a special type of data corresponding to the variable none. You can use the command type to see its type. So for example, here we see that when we type or when we execute the command type of 5, the output is an integer. If we print or execute the command type 3.0 or 3.0, we get a float. So these are some of the different scalar data objects available in Python. Accordingly, this allows for type conversions, or what we call casting. So with casting, we can convert an object from one type to another. So for example, if we execute the command float of 3, it converts the integer 3 to a float 3.0. Inversely, we can transform or change the type of a float into an integer, but in this case, one thing to pay attention to is the potential loss of partial data. So for example, in this case, if we execute int of 3.9, it removes the float value and returns the integer 3. So it's very important to pay attention when performing casting. To print the output to the console, you can use the print command. So for example, here if we execute the command print of 3 plus 2, we directly get the output as 5 without the word out, because this is a direct command for the computer to print whatever result. However, in some cases, the output is generated just to provide an interaction with the shell. Expressions now can be defined as a combination of objects and operators. So to form an expression, we combine objects and operators. An expression has a value which has a type. So the syntax for a simple expression is object, operator, object. As an example, we can have 3 plus 2 equal to 5. So 3 is an object, plus is an operator, and 2 is the second object. So here we show different types of expressions like the sum, the difference, the product, and the division. Note that here the division provides a float value. This modulo operator, for example, gives the remainder of I when divided by j. Another example here is of the power. So if you want to raise I to the power j, this is the correct syntax, which is double asterisk, which symbolizes double product or the power. So these are expressions of operators that can be applied on integers and floats. However, it's worth noting that these operators have an order of precedence. So starting with the power, and then this moves on to the multiplication and division, and then the addition and subtraction, and this is executed from left to right as they appear in an expression. So this is similar to the regular operator precedence in regular mathematics, in which we start with whatever is in the parentheses, then we move on to any power, then any multiplication or division, and then finally addition or subtraction. Another way or another potential expression is what we call binding. So binding is assigning a value to a variable name. So here, for example, we can define a variable pi, and we set the value as 3.14159. So this value is then stored in a computer memory. So the variable name determines or creates a memory space in which a value is stored. And then the equal sign binds the value to the right-hand side of the expression to the left-hand side variable. Why do we give names to values of expressions? We do that to be able to reuse names instead of values, and this makes it easier to change any code later on. And here we provide an example of how to calculate the area of a circle based on pi, which is a constant, and the radius. It is worth noting that in programming, we do not solve for x. So we can perform mathematical operations, but we are not performing math. So in an assignment, the expression to the right is evaluated and then assigned to a variable to the name left. Note that you can actually change bindings, or you can rebind variable names using new assignment statements. So the previous value may still be stored in the memory, but we lose the pointer to that value. So for example, if we go through this code, we first assign the value of pi, then we assign a value to the variable radius, we then calculate the area, and then perform a modification of the value of radius. So initially, the radius would have a value of 2.2, but then after executing the last expression, the pointer changes to 3.2. So now the memory location for 2.2 might still exist. However, the pointer from the variable radius now points to the memory location with the value 3.2. This concludes all of the videos for week 1. Thank you.